then R4. Okay. We are all configured. Let's take R2. Because it connects more devices. Very simple one command. Show CDP neighbors. And then press enter. This thing doesn't need to run. The device only needs to be turned on. This command will come out. But if there are no neighbors. Now these lists are empty. But you can see the name of the watch. It will now write you. Let's decipher what it means. I'll check out the neighbors of CDP now. First we look at these parameters. I will pick a few more important ones. Now here, R stands for router. For us now. View current neighbors. Has a neighbor's name. Because they have some messages with each other. It means. Let's take R3 as an example. R3 to R2. The local interface of R2 is. From which local interface is R3 discovered? R2 discovered from the local 02 interface. So this hold time is how long the two of them have been connected now. We don't have to worry about this. Further down here there is a platform. Shows Linux and Unix in the emulator. But in the real machine. This place shows the device model. But it has to be a Cisco device. In my emulator it shows. Such a Linux-based platform built. Because it is virtualized. So it doesn't have a device model. This also has a port ID. The port ID is the interface of the other party. That is. Now the local 02 interface of R2. The connected R3 interface is the 01 interface. From this diagram we can draw. Let me draw. We can blindly draw the topology. After you reach the NP stage. You can learn OSPF like this. Let's do a simple demo today. For example. This device is R2. There are now 3 wires connected to R2. They are its 2 interfaces. 1 interface. 0 interface. The 0 interface is connected to the 3 interface of R4. The 1 interface is connected to the 2 interface of R1. The 2 interface is connected to the 1 interface of R3. It is equivalent to this thing is to help you draw topology. Cisco equipment is available. All the drawings in this courseware can be used. But the premise must be Cisco equipment. Let's take a look at this graph. Is the same as what we just wrote. It's just that my painting is not as comprehensive as it is. Let's take a quick look. Interface 1 of R2 is connected to interface 2 of R1. R4 is connected to the 0 interface of R2. Opposite is the 1 interface of R3. Connected to the 2 interface of R2. It means. When you view neighbors on your device. You can quickly find out what equipment is connected to this device. And connected to which interface. Just to help you sort out the topology. Because when you come to the computer room in the future. You will find. The wiring in the computer room may be messy. For example. You go to a project cutover site. Probably because the person who worked on the project before was not present. A problem needs to be cut over. If there is no topology. You can check it. Simply look at how the specific topology is connected. CDP is this function. This does not need to be tested. If you want to experiment. Configure an interface address. Then you can see. Okay. Let's talk about ACLs at the end. Relatively speaking. ACLs are quite common. For ACLs and NATs. You may not know very well. But you may have heard of both techniques. The configuration is also very simple. ACL is called Access Control List. As the name suggests. It is for access control. It is actually equivalent to a function. Or you can also understand it as a strategy. Based on it to define the communication. Of the future data as a whole. Access control list. When configuring in Cisco, we call it access list. Techniques we have learned before. Either routing or switching. In fact, we all hope that the network can communicate. So we now pass the ACL. In fact, it is hoped that the network will not work. Of course, this impediment is conditional. We can control it by a means. That is, control whether some data in the network can communicate normally. This is the concept of ACL. Or, it is equivalent to restricting internet traffic in a certain range. You can do some other strategies based on it. It's not just a question of whether it works or not. We can also grab some data based on ACL. Perform some encryption on the data. Etc. Is equivalent to. You want to grab some data. Then operate on the data accordingly. There are quite a lot of controllable directions for this operation. ACL first has the concept of a list. You can understand this list as a list of arrests. If it meets the conditions of the list, it will be captured. ACL is divided into two steps. The first step is that we need to match the data according to some matching conditions. Then we will define actions for it based on these matching data. Action is nothing more than two. One is called permit. The other is called deny. That is, for a data, matching is either permit or deny. Let's take a look at the PPT. It has two application scenarios. Let's read it together. This drawing is actually quite intuitive. First of all, for internal. The two network segments are 1.0 network segment and 2.0 network segment. What about the two network segments? This red line is the 1.0 network segment. You will find the 1.0 network segment can access the internet. But the 1.0 network segment cannot access the company's internal server. The 2.0 network segment can access the internal server. But the 2.0 network segment cannot access the internet. It's like your company's finance department. This is the R&D department of your company. The R&D department accesses the internal server storing R&D data. Then other departments of the company do not have the right to access. The daily security requirements of the R&D department are relatively high. Some devices cannot be directly connected to the internet. Therefore, the planned 2.0 network segment does not allow internet access. For data sent in the future, we can here on the router do some corresponding ACL formulation. If the future matches the 1.0 network segment, then you can go online, but can't access it. If the future matches the 2.0 network segment, you can't surf the internet, but can access it. Let's do some targeted traffic filtering. This is called an ACL. Okay. Let's move on. This is another application scenario. Stream of interest. In the future, everyone who learns NP may come into contact with this thing. Let me introduce. Now the data can be matched according to the source IP address. For example, now the data is sent from this device interface. Then I can match the data. Take corresponding action. Assume that the red 1.0 data sent over is now matched. Then send it directly. It's like not matching. In fact, it was sent directly. Sent to the internet. The blue one is the 2.0 network segment. Stream of interest. This is a name for flow. After matching, you will find it encrypts this data. You will learn VPN in NP in the future. Then you will know why now when forwarding via the public network to encrypt some data. Because some internal company data may be passed on in the future. But I don't want to set up a dedicated line for cheap. However, the transmission of data must have some privacy guarantees. so we want to encrypt the data. For example, this is a head office. This is a branch. Some data is transmitted between the two through the internet.